Hi guys. So you just took the practice quiz for gas stoichiometry 1 and I wanted to walk through the questions in case you had some trouble. Let's take a look at the first one. It says using the reaction below, calculate what mass of lithium is needed to produce 5.2 liters of hydrogen gas at STP. Well, we know that we need to start with 5.2 liters of hydrogen gas. And I know for every 22.4 liters, that's 1 mole of hydrogen gas. And for every 1 mole of hydrogen gas in this equation, I need 2 moles of lithium. And for every 1 mole of lithium, I have 6.9412 grams. So if I put this into the calculator, 3.2 grams, that's 2 significant figures, will end up producing 5.2 liters of hydrogen gas at STP. So it's basically taking what I'm given, going backwards with stoichiometry to find grams of lithium. Let's take a look at the next one. It says if 0.87 liters of CH4 gas reacts with excess oxygen, what volume of CO2 gas is produced at STP? Well, in the same way, I'm going to start here and go through stoichiometry. If I have 0.87 liters of CH4, I know that for every 22.4 moles, or 22.4 liters, that's 1 mole. And so, once I convert to moles of CH4, I know for every 1 mole of CH4, I have 1 mole of CO2. And then finally, I will take my moles of CO2 and convert that to liters of CO2. And because it's a 1-to-1 mole ratio in this reaction, we see that the volume ends up being the same, 0.87 liters. So 0.87 liters of CH4 produces the same volume of CO2 gas because it's a 1-to-1 mole ratio. And that's 2 significant figures. For this last one, I have hydrogen peroxide and it decomposes to produce water and oxygen gas. It says store-bought hydrogen peroxide is this concentration, 0.88 molar. Well, if I have 0.50 liters of 0.88 molar hydrogen peroxide and it decomposes, how much oxygen will be produced? Well, to do that, I need to find how many moles this is. And then I can see from moles how many moles of oxygen and then how many liters of oxygen will be produced. And so to do that, I take my concentration and I multiply it by my volume. That's from when we were doing solution stoichiometry in the molarity, where the concentration times the volume gives me number of moles of H2O2 hydrogen peroxide. And that's 0.44 moles of H2O2. And for every 2 moles of that, of H2O2, I have 1 mole of oxygen produced. And for every 1 mole of oxygen, I have 22.4 liters. And so I end up, after putting this into the calculator, with 4.9 liters of oxygen gas. So if half a liter of hydrogen peroxide decomposes, this much oxygen gas will be produced. And we figured that out by calculating moles and using stoichiometry to go all the way to liters of O2. And this is all done at STP, standard temperature and pressure, which is why we can use this 22.4 liters for 1 mole conversion. I hope that helps. Good luck on that final quiz.